Welcome back, deep divers. Today, we're setting our sights on Jupiter.
They're the big guy.
The big guy, exactly. Now, you sent me some research about these strange dark spots
Oh, yeah.
that pop up at Jupiter's poles.
Mm-hmm.
And get this, you can only see them in ultraviolet light.
That's right. So,
It's pretty wild.
yeah, I think we're going to need to unpack this one.
Absolutely.
So before we get into these dark spots themselves,
Okay.
can we just back up for a sec?
Sure.
I always get hung up on the why. Why is UV light so important for studying planets?
Well, it's like different wavelengths of light
Okay.
kind of tell us different stories
Okay.
of a planet.
Gotcha.
And UV light that specifically interacts with the gases in a planet's atmosphere.
Oh.
So
Oh, yeah.
if we're looking at a planet in UV light, we're basically getting a sneak peek
Oh, cool.
at what's going on in its atmosphere, like
Speculations.
auroras, for example,
Okay.
or even like clues about what kind of gases are hanging out there.
So like a special lens?
Yeah, exactly. That lets us see the hidden stuff
Mm-hmm.
on these planets.
Yep.
Cool. So the research you sent over,
Yeah,
this is from the University of California, Berkeley,
that's right.
and it's titled Magnetic Tornadoes Reveal Jupiter's Darkest Secrets.
Mm.
I mean, come
I
on.
know, right?
Just the title.
Catchy.
It's catchy. All right. What are these dark spots?
Well, they're Earth-sized ovals.
Wow, Earth size.
Yeah, huge.
Yeah.
And they're found near Jupiter's auroral zone, so those are the light
nice.
shows,
Yeah.
the poles.
Mm-hmm.
And they look dark in these UV images because they absorb a ton of UV light,
Okay.
way more than the areas around them.
So we've got these like...
Yeah, like shadowy giants.
Yeah. Looking
Nice.
around the poles,
Yeah.
what's the catch?
Well, they're really unpredictable.
What do you mean?
Kind of appear and disappear.
Really?
Yeah.
Huh.
Unlike Jupiter's Great Red Spot,
Oh, right. Which
it's
like...
just been raging
Right.
for centuries.
Yeah.
These dark ovals, they're kind of like phantoms. They
Oh.
just pop in and out.
Okay, so how did scientists even find these things?
It's all thanks to Hubble,
Oh, of course.
a cosmic detective, right?
The best.
Yeah. And there's this project called the Outer Planet Atmosphere's Legacy, or OPAL.
Opal.
Yeah, it's way
Hard to
easier.
mistake.
And basically, Hubble's been taking these yearly snapshots
Oh, okay.
of Jupiter, Saturn, Uranus, and Neptune.
So like a yearly checkup
Yeah.
for the gas giants.
Mm-hmm.
Okay, so what did these opal pictures tell us?
All right, so they found a dark UV spot
Okay.
at Jupiter's south pole, about 75% of the time,
Wow.
between 2015 and 2022.
Okay.
When they looked at the North Pole,
Yeah.
they only found one dark spot out of 8 images.
So more active in the south.
Yeah, it seems that way.
Interesting.
Yeah.
Why is that? And what's causing these spots in the first place?
Well, now things get really interesting.
like, oh,
Because scientists think these spots could be telling us about some unusual stuff happening deep down in Jupiter's atmosphere.
okay.
And it all comes back to its crazy strong magnetic field.
Right. Jupiter's magnetic field.
Way stronger than Earth's.
Yeah, yeah.
And it interacts with the atmosphere in ways we're just starting to understand.
When you say deep down, how deep are we talking?
Deeper than on Earth, for sure.
Okay.
The Earth's magnetic field, it mostly protects us from the sun's radiation.
Right.
But Jupiter's, it's so strong, it stretches way out, creating this huge magnetosphere.
Okay.
And this magnetosphere, it interacts with charged particles, not just from the sun,
Okay.
but also from one of Jupiter's moons, Io.
Wait, Io, the pizza moon.
Yep, that's the one.
Okay.
Remember all those volcanoes erupting?
Yeah.
Well, those eruptions, they spew out a bunch of charged particles,
Oh, wow.
which form this plasma sheet around Jupiter.
So this plasma sheet, made from stuff erupting from Io, is
Mhm.
interacting with Jupiter's intense magnetic field.
Exactly. And that's where this magnetic tornado idea comes in.
Okay, I'm listening.
So picture this. You've got Jupiter's magnetic field lines,
Yeah.
specifically in the upper atmosphere, the ionosphere,
Mm-hmm.
and they're rubbing against this plasma sheet.
So there's friction.
Exactly.
Okay.
And that friction generates these powerful spinning forces.
It's giant tornadoes.
Yeah, kind of.
But magnetic.
Mm-hmm. Magnetic tornadoes.
Whoa.
And these tornadoes, they reach deep into Jupiter's atmosphere.
Okay, so they're stirring things up.
Yeah, big time.
But how does that make the dark spots?
Imagine a tornado on Earth kicking up dust and debris.
Right.
Same idea here.
Okay.
These magnetic tornadoes, they churn up this layer of haze in Jupiter's atmosphere. And when this haze gets stirred up, it gets denser.
Okay.
And that's what makes it look dark in UV.
So it's not the tornadoes themselves we're seeing.
Right.
It's the stuff they're kicking up.
Exactly.
That makes sense.
Yeah.
But you said earlier these dark spots are really hazy.
Oh, yeah. Super hazy.
You're like, how hazy?
One of the researchers, Shi Zhang,
Okay.
found that the haze in these spots, it's 50 times thicker.
50 times.
Yeah. Than the haze around it.
Okay, so that's got to mean something.
Right. It means the haze isn't just sitting there.
Yeah.
It's being stirred up and concentrated by these magnetic tornadoes.
So they're dredging up stuff
Mm-hmm.
from deep inside.
Exactly.
Huh. Could they be making new haze too?
That's a great question.
Yeah.
And we don't know for sure yet.
Okay.
It could be they're bringing up old haze,
Mm-hmm.
or maybe they're making new haze
Wow.
with all that mixing.
So we've got these powerful magnetic tornadoes
Yeah.
from Jupiter's magnetic field and the stuff from Io,
Mm-hmm.
and they're ripping up this haze,
Exactly.
making those dark spots. And we know they're not always there,
Right. They come and go.
unlike the Great Red Spot.
Mhm.
So how long do these spots typically last?
Well, it seems like they take about a month to form, and then they vanish within a couple of weeks.
Wow.
Yeah.
It's short, right?
Yeah, that's a short life for something so big.
I know. Makes you wonder if we're only seeing a tiny part of a much bigger process.
Right. Like there's a whole other story happening under the clouds.
Exactly. And it highlights how much we still don't know about Jupiter's atmosphere.
Okay, so we've got phantom dark spots, magnetic tornadoes,
Uh-huh.
a haze mystery.
Mm-hmm.
What's next?
Well, so far we've been talking about Jupiter as its own little world.
Right.
But what's really cool is how these discoveries could connect to other planets, too.
Really?
Yeah, even beyond our solar system.
Ooh, okay. You have to tell me more about that.
Let's take a quick break, and then we'll dive into that.
Sounds good to me. Okay, so we've got these magnetic tornadoes on Jupiter,
Mm-hmm.
whipping up all this haze, creating these dark spots we can only see in UV.
It's wild, right?
It is wild, but you were saying it connects to other planets too.
Yeah, it's not just a Jupiter thing.
Right. It might give us clues about what's happening on other gas giants too.
Oh, wow. Like Saturn, Uranus.
Possibly. Think about it. They all have strong magnetic fields,
Right.
and they've got moons.
True, though those moons aren't as explosive as Io.
Yeah, probably not as many volcanoes.
But
But they still have charged particles
right.
interacting with those magnetic fields.
So it's not about having like a carbon copy of Jupiter and Io,
Right.
but more like similar ingredients, similar results.
Yeah, exactly. And it goes beyond our solar system, too.
Wait, really?
Yeah. We're finding all these exoplanets.
Planets around other stars.
Yeah, and a lot of them are gas giants.
Ah,
So if we could figure out what's going on with Jupiter,
yeah.
it might help us understand those distant planets, too.
That's incredible. It's like using Jupiter.
Like a giant lab.
Yeah, to
Yeah.
study the whole universe.
Exactly.
Okay, but back to Jupiter for a sec.
Sure.
We saw those differences between the North and South poles.
Mm-hmm. More activity in the south.
Why is that?
Well, one idea is that it has to do with Jupiter's magnetic field.
Okay.
Specifically, its tilt.
Tilt, like Earth's axis.
Yeah, like that. Jupiter's magnetic field is tilted, too.
Huh. So it's not perfectly lined up?
Nope, it's off by about 10 degrees.
Okay, and that matters because
Because it means the South Pole's magnetic field lines are more connected.
to Eo's plasma sheet,
Exactly.
so the South Pole is getting hit harder
Pretty much.
by those charged particles.
Yeah, which could explain why we see more activity there.
Wow, it's crazy how,
2028.
like, something as small as a tilt
Mhm.
can make such a big difference.
It all comes back to that interconnectedness.
Right. It's not just the planet itself.
Right. Oh,
It's the moons, the magnetic field, the sun, everything.
it's a whole system.
Yeah, and that magnetic field is insane.
Oh, yeah, super powerful.
The Juno mission, right?
Mm-hmm. Juno's been up close and personal.
Did they find out more about it?
Oh, yeah, tons.
Like what?
Well, first of all, it's huge.
Bigger than we thought.
Way bigger. It stretches out way past Jupiter.
So like a giant shield.
Yeah, basically. Protecting Jupiter from the solar wind.
Okay, so it's a protector,
Uh-huh.
but it also helps create those magnetic tornadoes.
Right. It's kind of doing both.
How does that work?
Well, that magnetosphere acts like a funnel, basically,
Okay.
channeling those charged particles from Io towards the poles.
Ah, so that's what creates the friction
Exactly.
that starts those tornadoes spinning.
Yep, that's the idea.
It's a protector and a catalyst.
It really is. Shows you how complex these systems are.
For sure. And it's not just a one-time thing.
Nope, it's constantly changing.
Yeah, like those dark spots.
Mm-hmm. Appearing and disappearing.
The auroras are always shifting.
Yep.
Even those bands of clouds we always see.
It's a world in constant motion.
Yeah, it really is. And those dark spots, they're
Like little glimpses
yeah.
into what's happening deep down.
And we're just starting to understand it all.
Exactly.
Yeah.
It shows how much we still have to learn, not just about Jupiter.
But about all the gas giants.
Mm-hmm. Here and in other solar systems.
It's kind of humbling, isn't it?
It is, but it's also exciting.
Yeah. All that potential for discovery.
Exactly. Who knows what we'll find next?
Okay, so we've learned about these phantom dark spots, magnetic tornadoes, the haze mystery, and how it all connects to the bigger picture.
It's pretty amazing, right?
It is. So, for our listeners, what would you say is the biggest takeaway here?
I think it's the interconnectedness of everything.
Yeah.
How a moon, a magnetic field, even some haze.
It's all connected.
Exactly. And understanding those connections
Is how we unlock the secrets of the universe.
That's what it's all about.
Well said. So keep those connections in mind as we continue to explore Jupiter and beyond.
There's always more to discover.
That's right. Until next time, deep divers, keep exploring.
It really makes you think, doesn't it?
It does. When you consider the scale of these magnetic tornadoes on Jupiter.
Oh, yeah. They're immense.
It just blows my mind.
And to think
Yeah.
that's just one tiny piece
Right.
of this giant complex system.
It really puts things in perspective.
It does.
And it's not just what we're seeing, right?
What do you mean?
Well, it makes you wonder what else is out there.
Oh, yeah.
What other amazing things we haven't discovered yet?
It's got to be a ton. I mean, we're just scratching the surface with all these new ways to observe the universe.
Right. Like we've got infrared, X-ray, gamma ray.
All these different lenses to see the cosmos.
Yeah. Who knows what's hiding out there?
It's exciting, for sure.
It is. But also a little,
Humbling.
yeah, humbling.
Yeah, it makes you realize how much we don't know.
Exactly. It's like we're just starting to understand the universe.
Even with these discoveries like those magnetic tornadoes.
Yeah. What about them?
Well, who would have thought that studying dark spots on Jupiter would teach us so much about planets in general?
Well, I see what you mean.
Like, it's not just Jupiter, it's a whole new way to think about these giant planets.
Yeah, it's like finding a piece of a giant cosmic puzzle.
Exactly. And every new discovery, it adds another piece.
We're getting closer to the big picture.
Slowly but surely.
It's amazing how these breakthroughs come from the most unexpected places.
It's true. You never know what's going to lead to the next big discovery.
So as we wrap up our deep dive into Jupiter's dark secrets, what's the one thing you want our listeners to remember?
I think it's that connection.
The connection.
Yeah, how everything's tied together.
Like the moon, the magnetic field, the haze.
Exactly. And understanding those connections.
Yeah.
That's the key to figuring out the universe.
Wow. That's a pretty powerful thought.
It is, isn't it?
It is. Well, on that note, I think we'll leave our listeners to ponder
Those mysteries.
the mysteries of Jupiter and the universe beyond.
The big universe out there.
That it is. Until next time, deep divers, keep exploring and keep asking questions.